In part B, we have to evaluate the integral of g from 1 to 6. This function g, it has two different functions. From 1 to 3, it's still part of the piecewise function, and from 3 to 6, it is the quadratic function, which means we need to divide this integral in two different integrals. First, we need to integrate function g from 1 to 3, and we also need to integrate in part B. We have to evaluate the integral of g from 1 to 6. In part B, we need to evaluate the integral of g from 1 to 6. This function is not only one function, it's two functions. From -5 to 3 is still the piecewise linear function, and from 3 to 6 is the quadratic function. So we need to use the quadratic from 3 to 6, and we need to use the piecewise from 1 to 3. So we need to divide this integral in two different integrals. The integral of g from 1 to 3, and also the integral of g from 3 to 6. The integral from 1 to 3, as we can see, is a square under the function, and the area of the square is 2 times 2, which is 4. And in the quadratic, we need to integrate the function. So we need to find the integral from 3 to 6 of 2x minus 4 to the power of 2. So 4 plus, and then to integrate, the best thing we can do is to develop first. We can take the 2 outside because it's a constant. 3 to 6, and then this is x squared minus 8x plus 16 dx. And now we need to integrate. I'm going to continue this here. 4 plus, then integral of x squared is x to the power of 3 over 3. Integral of negative 8x is negative 8x squared divided by 2, and plus 16x. Everything evaluated from 3 to 6 and multiplied by 2 because we took the 2 outside because it was a constant. So equals then 4 plus, and then we need to substitute the 6. 6 times 6 is 36 times 6. So to integrate, 4 plus 4 plus, and now the integral of this function, since what is inside the bracket is the derivative of x minus 4 is 1, then we can just integrate as if x minus 4 was just one variable. So it's 2, and then this is x minus 4 to the power of 3 over 3, and everything evaluated from 3 to 6. We don't need to use the chain rule. Four plus, and then to integrate, since what is inside the bracket is x minus 4 and the derivative will be 1, yeah, we don't need to do u substitution or something like that. We can just integrate directly. So 2 times, and then x minus 4 to the power of 3 over 3, and this evaluated from 3 to 6. I took the 2 outside because it's a constant. Then I'm going to continue at the left side, equals, and then 4 plus, and then we substitute the 6. 6 minus 4 is 2. 2 to the power of 3 is 8, divided by 3, 8 over 3, times 2 will be 16 over 3. And we subtract the same with the 3, substituting the 3. 3 minus 4 is negative 1, negative 1 to the power of 3 is negative 1, negative 1/3 times 2 is negative 2/3. So negative 2/3 with the minus becomes plus. Yeah, remember when we substitute, we subtract the lower one. So minus times minus becomes plus. So equals, now we can, the 4 is 12 over 3, 12 over 3 plus 16 over 3 plus 2 over 3. So 12 plus 16 is 28, plus 2 is 30, 30 over 3 is 10. So the integral from 1 to 6 of the function g is equal to 10.